Okay, let's talk about one of the toughest nuts to crack in the climate fight, air travel. It's a huge challenge, but what if the solution, the path to greener skies, is something that at first sounds completely backwards? We're going to dig into some new research that flips what we thought we knew about biofuels completely on its head. To really get a sense of just how big this challenge is, I want you to remember one number: 35 billion gallons. That's the goal the US has set for producing sustainable aviation fuel, or SAF, by the year 2050. Now, that's not just to supplement the fuel we use now. That's enough to replace every single drop of conventional jet fuel. It's a massive, massive target. Right, so that number, 35 billion gallons, it immediately makes you think, okay, wait a minute. This stuff, this sustainable fuel, it has to be grown from special energy crops. So the big, obvious question is, where in the world are we going to find the space to grow all of it without causing a whole bunch of new problems? And that question leads us straight into a really familiar debate, one we've been having for a long, long time when it comes to biofuels. It's the classic fuel versus food dilemma. You know, the high cost of trying to grow our fuel right here on the ground. It's a pretty straightforward conflict, right? On one hand, we've got all this land we use to grow food, to feed, well, everybody. On the other hand, if we want this greener jet fuel from crops like miscanthus and switchgrass, we have to plant them somewhere. And that somewhere is often land that could be used for farming. So they're competing for the exact same real estate. So for years, the common sense thinking on this has been, this is probably a bad idea for the climate. I mean, it makes sense, right? You plow a field or a grassland to plant these fuel crops, and boom, you release a bunch of carbon that was stored in the soil. That puts you in what scientists call a carbon debt right from the start. Not only that, if you take land away from food, prices go up, which might just encourage people to clear more land somewhere else to grow crops. The basic assumption was simple. Using more land for fuel means more emissions. Period. But what if that assumption is wrong? This is where things get really, really interesting. New research is suggesting something that sounds kind of crazy. What if using more land for fuel could actually be better for the climate? Yeah, check out this quote directly from the study because it's really the core of this whole thing. It says, contrary to expectations, we find that scaling up fuel production by converting more cropland and more non-cropland lowers its net greenhouse gas intensity. I mean, wow, that basically turns the whole argument right on its head. Okay, so this chart here shows you exactly what they're talking about. See how on the bottom, as you move to the right, we're making more and more of the sustainable fuel? That means we're using more and more land. Now look at those black dots. That's the key. That's the climate impact per gallon. And you can see it. It's going down. So the more we scale up, the cleaner the fuel actually gets. It's wild. So what on earth is happening? How does that even work? Well, the answer is literally right under our feet. It's all about a hidden superpower that these specific energy crops have. I know, it's the big question, isn't it? It just feels like it shouldn't be possible. How can taking over more and more land end up being a net positive for greenhouse gases? It seems to break all the rules. Okay, the magic word here is soil carbon sequestration. Here's the deal. These aren't your typical farm crops like corn that get replanted every year. These are perennial crops, things like miscanthus, and they have these incredibly deep root systems. Think of them as giant, natural carbon sponges. They are just amazing at sucking CO2 out of the air and then packing it away deep in the soil where it stays locked up for a long, long time. The best way to think about it is like a bank loan. So when you first convert the land, you release some carbon. That's your loan, your initial carbon debt. But then every single year, these new crops start making huge carbon deposits back into the soil. And what's amazing is how fast you pay back that loan. The study says it takes just 5 to 7 years. After that, you've not only paid off the debt, you're actually building up carbon savings in the soil. You're in the green. So the bottom line is this. These special crops are just so good at capturing carbon that they more than make up for the carbon that was released at the start. It's a pretty powerful trick that nature has up its sleeve. Okay, so this all sounds great, right? A climate win. But, and this is a really big but, it is not a free lunch. Getting these greener skies comes with a very real cost, a price we'd have to pay right here on the ground. Remember that 35 billion gallon goal? Well, to even get close, we'd need to convert about 29 million hectares of land. Now, that's just a number, so let's put it in perspective. That's an area about the size of the entire state of Arizona. Just think about that. An Arizona-sized farm, just for jet fuel. It's a staggering amount of land. And what happens when you take a chunk of land the size of Arizona and dedicate it to fuel? Well, you guessed it, food gets more expensive. A lot more expensive. The models show that to hit that big goal, corn prices could jump 15%, soybeans 20%, and wheat up to 25%. That's not some abstract number. That's something you'd feel every single time you go to the grocery store. And we're not just talking about prime farmland here. To get to these numbers, we'd need a mix of everything. We'd have to convert existing cropland, sure, but also what's called marginal land, stuff that's not great for farming anyway, and even grasslands. It's a total landscape transformation. This table really lays out the tough choices we'd have to make. Look at this. If we say, okay, you can only use existing cropland, we don't make as much fuel, and food prices could shoot up by 30%. Ouch. But if we open it up and say you can also use marginal land and grasslands, look what happens. We can make way more fuel, and the hit on food prices is smaller. But the trade-off is pretty obvious. We'd be converting a lot more of our natural and semi-natural landscapes. So that's really the heart of it, isn't it? It's a classic three-way trade-off. It's a balancing act between the kind of land we're willing to give up, how much green fuel we can actually make, and what we're all willing to pay for our food. And that leaves us with a really tough question to chew on. The science is fascinating. It shows there's this unexpected climate upside, but it's not free. So the real question for all of us is, to clean up our skies, what price are we actually willing to pay right here on the ground?